Differentials. Okay, so let's think of a differential as a tiny change in a quantity. Okay, so let's say that we have a function f, and I'd like to know how much does f of x change if I add a tiny change to x. So in other words, what is y plus delta y if I do f of x plus delta x? Okay, and that can be kind of difficult to do. However, calculus lets us get a really fast and fairly easy approximation. Here's how it works. Remember that the instantaneous rate of change of y with respect to x is the derivative. So here's our tiny change in y, which corresponds to delta y, and here's our tiny change in x, which corresponds to delta x. So if I multiply both sides, remember we started with dy over dx equals f prime of x. If I multiply both sides by dx, I get that my tiny change in y is equal to the derivative with x plugged in times the tiny change in x. So that is a differential. So you ready to find one? Find the differential of y equals the sine of 3x. Okay, dy is going to be f prime of x dx. Well, the derivative of the sine of 3x is the cosine of 3x times the derivative of 3x because of the chain rule, and then we'll multiply all of that by dx. So I would write this as 3 cosine 3x dx. That is the differential of y equals sine 3x. So let's apply this to an example. Let's use differentials to estimate the sine of 3 of pi over 3 plus 0.1. So we'll let pi over 3 be x, and the 0.1 is the tiny change in x. So that'll be our dx. Okay, so f of x plus delta x is going to be approximated by f of x plus f prime of x dx. Okay, well, that's going to be f of pi over 3 plus f prime of pi over 3 times 0.1. Okay, f of pi over 3 is the sine of 3 times pi over 3. F prime of pi over 3, well look, we just found that right up there, right? So it's going to be 3 cosine of 3 times pi over 3, and then we multiply by dx. Okay, well, that's sine of pi, which is 0, and cosine of pi is -1, times 3 is -3, times 0.1 is -0.3. Now, this is just an approximation, okay? It's not the exact change in y if we added 0.1 to pi over 3. So to compare, let's go ahead and do this on our calculator. The sine of 3 parentheses pi divided by 3 plus 0.1 close parentheses, and we get -0.2955, which is pretty close to -0.3. Now here's another nice application of differentials. So we can use differentials to estimate the square root of 16.5. So we will let f of x be the square root function. We'll have x be a number that we can take the square root of easily, in this case 16, which leaves delta x to be 0.5. Okay, so f of 16 plus 0.5 is going to equal f of 16 plus f prime of 16 times 0.5. Okay, let's get f prime of x. Well, if f of x is x to the 1/2, that's the square root of x, then f prime of x is going to be 1/2 x to the -1/2, which is 1 over 2 root x. All right, let's plug our numbers in now. So f of 16.5 is going to be approximately the square root of 16 plus 1 over 2 root 16 times 0.5. Okay, the square root of 16 is 4. And that's 1 over 2 times 4, which is 1 over 8 times 1/2. And I get 4 plus 1/16, which is 65/16. Let's compare once again with our calculator. Okay, so we're saying that the approximation of the square root of 16.5 is 65/16, which is about that, 4.0625. And then let's actually do the square root of 16.5, and you can see that they're very close. Okay, one more example. If we have this function, let's use it to estimate. Let's use differentials to estimate f of negative 0.99. So what we're going to say is that negative 0.99 is equal to negative 1 plus 0.01. So there's our x, there's our dx. Okay? So f of negative 0.99 is going to equal f of x plus f prime of x dx. Okay, that's going to be f of negative 1 plus f prime of negative 1 times 0.01. Okay, f of negative 1 is negative 1 to the 4th plus 1. And f prime of negative 1, well, the derivative of that is 4x cubed. So f prime of negative 1 is going to be 4 times negative 1 cubed, and we'll multiply that by 0.01. Okay, negative 1 to the 4th is 1, plus 1 is 2. 4 times negative 1 cubed is negative 4, times 0.01 is negative 0.04. So we get 1.96. Shall we compare that to what the calculator tells us? I'm going to go negative 0.99 raised to the 4th plus 1, and it's 1.9606. So that's very close to what we approximated with differentials.